Okay, right. Good morning to you all from a freezing Bedwas High School. It is absolutely Baltic. Here is your starter activity. It's finding out an area of trapeziums. I'm sure you all remember to work out the area of a trapezium. You add up the parallel sides, you half the result of that, and then multiply by the distance between them. We usually call that the height, right? But if you look at, for example, question 5 on this screen, the distance between them isn't really a height, is it? It's more of a horizontal length, right? But we usually say the height. So quick 30 seconds, add up the two parallel sides, half that, multiply by the distance between them, and all of these answers will be centimeters squared. All right, so 30 seconds on that while I try and warm myself up. Some of these you can do in your head. Right, try and get two more done. Last couple of seconds. Right, tick these off. Let's have a look. Number 1, 8 and 4 is 12. Half of that is 6. 6 5s are 30. So number 1 is 30 centimeters squared. Number 2, 5 and 3 is 8. Half of that is 4. 4 6s are 24 centimeters squared. Number 3, 8 and 9 is 17. Half of that is 8.5. I need a calculator. 8.5 times 8 is 68 centimeters squared. I should have done that in my head. That's embarrassing. Number 4, 5 and 7 is 12. Half of that is 6. 6 6s is 36 centimeters squared. Number 5, the parallel sides are 4 and 9. I'd want to get 13. Half of that is 6.5. 6.5 times 7 is 45 centimeters squared, I hope. Number 6, 6 and 11 is 17. Half of that is, oh, this is the same as the other one. Half of that is 8.5. 8.5 times 8 is 68 centimeters squared. Number 7, 4 plus 7 is 11. Half of that is 5.5. 3 5.5s is 16.5 centimeters squared. And the last one looks a bit dodgy, right? But it's still a trapezium. It still has one pair of parallel sides. But the perpendicular height, or distance between them, I should say, is given outside of the shape. 6 plus 1 is 7. Half of that is 3.5. 3 3.5s, I think, is 10.5 centimeters squared. Can someone please type in the chat that they had some of those right, so I know I can move on? Anybody, please? So I know that that worked at least. Thank you, Carmen. Thank you. Awesome. Thank you, everybody. Right, so let's crack on with the proper lesson then, right? So this is about finding the area under a curve. Now, at GCSE level, you won't actually be able to do it completely accurately. You will only be able to estimate it, right? Once you get to year 12, we'll show you something called integration, which allows you to find the accurate area under a curve. It's really cool. But today we're just going to estimate it. Most of the curves you will experience on your GCSE paper will be from a velocity time graph, right? A speed time graph. And that's what we're going to look at today. And of course, you may or may not remember that the area under that graph is the distance traveled. All right, so if you think of your distance, speed, time, which is what you're going to work on with me this week in your My Maths and your manga as well, right? The area under the velocity time graph is the distance traveled. And normally at GCSE level, the graph will have straight lines and you'll have a triangle and a rectangle. But for the A star question on the higher tier, it will be a curve. And you will have to estimate the area under that graph using trapeziums, right? So let's have a look. So here's a velocity time graph. Velocity up the vertical axis in meters per second, time along the horizontal axis in seconds, right? And we want to find out, I think they're going to ask us, yeah, what's the distance traveled in the first 10 seconds of that journey? So we need to find the area under that graph. So as it says there, we could use rectangles, right? So if I draw rectangles, and at each point like that, that's going to give us a half decent estimate at the area under that graph, right? But hopefully you can see my mouse moving here. All of this yellow here above the line is not needed. That's not needed. That's not needed, or that, or that. So that's not the best estimate we could actually use. Right, as it says, there are large areas above the curve that we don't want. So what we're going to use triangles and trapeziums instead, and have a look at how much less wastage there is here now, right? So here's my curve. Let's put a triangle underneath that first part. There's very little wastage there. There's a little bit under the graph halfway up the triangle there, as you can see. Let's do a trapezium then for that next part. Much more accurate, much less area wasted. Same for that one, same for that one, and same for that one, right? So this is why we use trapeziums instead of rectangles to estimate the area, because it's still not perfect, but you can see there's much less of an error in the estimation. All right, so what we're going to do, we're going to work out the area of each of those shapes and then add up the total to get the total area, right? Simple. So it tells us the first 10 seconds of a cyclist journey, calculate an estimate for the distance traveled in these 10 seconds. Use 5 strips of equal widths. Right, now, you were going to do this one straight away. You're going to get straight into it, right? So the area of this red triangle is half the base times the height. The base is 2, so it's half of that, times by the height, which is 5. Then you've got 4 trapeziums to work out, okay? Now don't forget, the parallel sides here now are vertical. So for this first trapezium, this parallel side has a length of 5. This parallel side has a length of 7. So you'll add those up, 5 plus 7. You will then half that answer and then multiply by the distance between them, which for all of these trapeziums is 2. Okay? Then you'll go into this trapezium. This parallel side is 7. This one is 8. You will add up those, half it, multiply by the distance between, which is 2. So every time the height, if you want to call it that, or the distance between the parallel sides is 2. All right, so I'll give you 60 seconds to try and work that out, right? So a triangle, 4 trapeziums, work out the area of each, add them up. And then we'll talk about that last question in a minute. Someone has just punged, so they might be waiting to be admitted to the room. I'm just going to come out of it 1 second, just 1 second. Try not to cheat and look at the answer. No, I don't know. Okay, sorry, don't know what happened there. So hopefully now you're on the 3rd or 4th trapezium. Anybody brave enough to chuck an answer in the chat? But don't forget, even though we're working out an area, so your gut instinct would be to call it meters squared, when we actually interpret it, we are working out a distance. So your actual units will just be meters. I've no idea if anybody's typed anything in the chat. Anybody? I don't think it pings, I'm not sure. I'm gonna have a cheeky look. No answers in the chat. Ooh. Oh, someone put one in. Who's that? Coffee. Cheers, mate. He's gone for 66. And he's much better at maths than me, so he's probably right. So we'll have a little look now. So here's your mathematics, right? The red triangle was half the base times the height. And then those trapeziums, the parallel sides were 5 and 7, 7 and 8, 8 and 8.5, and 8.5 and 9. Right? So you're going to need to calculate this definitely for those last ones. Take your time pressing those buttons, add them all up. And the area came to 66 meters squared. But the interpretation of that is the distance traveled is 66 meters, right? So the mathematics was easy, wasn't it? He was adding up a couple of numbers, halving it, and times in by 2 each time. So don't be put off by the maths. It's just interpreting it that can sometimes be tricky. This last question is a beauty. It's only worth 1 mark. Is this area an overestimate or an underestimate for the distance traveled? And I'm sure you'd all agree it's an underestimate, because our estimation of the trapeziums here, I've left a little bit of white there that you can see on that first green trapezium, and there's a little bit of white between the triangle and the graph as well. So there's a little bit of area we've not accounted for, which means it is an underestimate. Okay, Brill. Right, your turn to do another one. We're going to do about 5 or 6 of these today. So here's the next one. The graph below shows the speed of a car. So again, it's a velocity time graph as it approaches a junction. Calculate an estimate for the distance traveled. So the knowledge you have to have is that the distance is the area under a velocity time graph, and you have to find the area under that graph, right? So first bit's easy. That's just going to be a rectangle, length times width. And then I'm going to invite you to create 2 trapeziums there and then a triangle to finish, right? So length times width for the purple. The triangle is half the base times the height. And then those 2 trapeziums, get your parallel sides, add those up, half it, and multiply by the distance between them. 4 shapes, get the areas, add them up, off you go. Might as well look up a dad joke while are you doing it? I know how much you look forward to these. 30 more seconds. Oh, this is terrible. Why do nurses always carry a red pen with them? In case they need to draw blood. I'm sorry about that. I've actually offended myself. Right, okay, let's go through it. The rectangle was 7 times 3. The first trapezium, the parallel sides was 7 and 6. Add them up, half it, multiplied by the distance between them, which is 2. The second trapezium was, the parallel sides was 6 and 4. Add them up, half it, multiplied by 2. And the triangle, half the base times the height. Easy peasy. Add them all up, and you hopefully would have got 48 square units, which represents a distance of 48 meters, and it is an underestimate again because you can blatantly see 3 bits of white graph that we haven't accounted for with our estimation. Right, I'm assuming that was all fine. Nobody said anything, shocker. So let's look at some proper questions, right? This is the type of stuff you'd get off an exam. If you haven't been able to print them, doesn't matter. I'll leave that up on the screen for a minute. And I'm going to then do it on the camera, even if you just have to watch, doesn't matter. I want us to work out the area under these curves here. I want to split the one on the left into 3 equal lengths, right? The one on the left, I want to split into 3 equal length trapeziums. And the one on the right, I want us to split into 6. And we'll talk about the accuracy of each, right? So the one on the left, we're going to split into 3. The one on the right, we're going to split into 6. And we're going to work out the area of each of those. So have a go if you can. Where's it go? Right. Can someone confirm that they can see those 2 graphs on the screen, please? Thank you all. Right. Now I'm going to go onto the camera. Right. Bear with me. Here we go. Right. So let's split this one into 3. So I'm obviously going to split it there and make a triangle there. I'm going to split it there and make a triangle there. So for this middle bit, if I cut it off there, I've got a big gap of white there, a big gap of white there, and a big gap of white there. So I could actually compensate for these 2 underestimates by overestimating here. I haven't actually used a trapezium on that one. So I hope you would agree. This is half the base times the height. Base is 10, half of that is 5, height is 30. So that's worth 150. This is a rectangle of length 10, height 40. So that's worth 400. And this is another triangle, symmetrical, so it's the same as the first one. So that's 150, giving us a total distance of 700, whatever the units are. All right, now, that is quite inaccurate, isn't it? And we didn't actually use a trapezium. And the reason I asked you to do that and split the next one up into 6 was to talk about accuracy. So for this one, let's split it up into a trapezium there, triangle there, a triangle there, a trapezium there, and there. I'm going to give you a bit of time to try this one on your own, right? Let's label them all. 1, 2, 3, 4, 5, and 6. And the point I'm trying to make by doing this, and you will especially need this at A level, is the thinner the width of the trapezium, or the more strips you have, the more accurate your answer will be. And they like to ask that, right? They'll usually tell you how wide to make your trapeziums, but then they'll add at the end, how can you make your answer a better estimate? And of course, to do that, you just need to make the trapeziums thinner, and you'll have more of them, and you'll have less graph unaccounted for there, okay? So I'll give you 60 seconds. If you can see the numbers, and let's see if we can work out the area under this curve here. If it looks a bit dodgy, go for the easy number, right? So look at trapezium 1. Let's call that 28. So I've got a half of 28 plus, let's be nice and call that 20, is it? And that will be multiplied by the distance between them, which is 5. So that's what you're going to get for trapezium 1. Right, you have a little work through that for 60 seconds. Anybody got anything yet? Oh, it's so weird that none of you speak. Do any of you speak to any of your other teachers when you're having lessons like this? Is it just me that you're blanking? So why are you this quiet when we're in school then? Can't do. Shut up half the time. Okay. Time to go through it. I think you get the idea. So we just want to work through these last couple. Okay, and then we'll start your quiz. All right. This is what I got. So if you have slightly different values than me, well, that's fine, right? After all, we are only estimating. Like this one here, I initially called it 43. And I thought, oh, why? Why? It's just going to be difficult. And then I changed it to 44. Okay. So trapezium number 1. I got 28 plus 20, that's 48. Half of that is 24 times 5, that's 120. Trapezium 2, 20 and 10, 30. Half of that is 15. 5 of them is 75. Then it's just a triangle. Half the base times the height. So that's 25. This triangle was symmetrical and the same as this one, so that'll be 25. This one here. So this parallel side was 10. This parallel side I got as 44. Add them up, 54. Half of that, 27. 5 27s, 135. And then the last bit, this parallel side is 44. This one is 30. Add them up, that's 74. Half of that is 37. 5 37s, 50, 185, I think. So now I need to add all of these up, and that'll give me the area under the curve and hence the distance that that object has traveled, right? So we've got 100, 220, 320, 420, 445, 455. Anybody get 565? Or did I just completely mess that up? Anybody? Oh, tell me if you think I got it wrong. Oh, I'm getting nothing off you. Right, thank you, Mal. You got similar to that. Well, that's fine. If we're in the right ballpark, because it's an estimation, that's fine, isn't it? I'm just checking I added them up right. 565. Nobody else want to say they had something similar? Well done, Kiri. Thank you. Really appreciate that. Right, brilliant. Now that was a well done, Alicia. Well done, Johan. Awesome. Well done, Paul. Brilliant. So that's it. They can't really get any more difficult than that. Okay, there's some tricky numbers there. And that is how we use the trapezium rule to calculate area under the curve. Right? So I believe I did send you another question. So here's the next one. This is straight off the exam paper. You could tell by the font, and you can see here they're awarding 3 marks. Right, so it's a velocity time graph. So your brain's got to go, oh, they're going to ask me to work out the distances traveled here. I know I'm going to have to make trapeziums. So if you've managed to print this off, great. Have a go at doing it. If you haven't, it doesn't matter. You can watch me do it. You can still do the mathematics, right? It says find an approximation for the distance traveled. So that's the knowledge. You've got to know I'm working out the area by the particle between t equals 0 and t equals 4. Now, a couple of options. We could split it into 4 trapeziums, or we could split it into 8 trapeziums. Now, it's only worth 3 marks. So my gut instinct is 4 trapeziums will be plenty. 8 will be more accurate, and they might ask us about that later, but 4 would be plenty. So there's my first section. There. Here's my next one. There. Now this is the dodge. This is the dodge bit. Do I go there or up to there? Tell you what, I'm going to go up to there. Whoop, that's meant to be straight. I'm going to go up to there because this little bit extra is sort of compensating this bit that we're not counting for. And then the last one, I'm going to go from there to there. Okay, so that's what I'm going to attempt. I'm going to attempt that one, that one, that one, and that one. And as you can see, the numbers are not that difficult. So each width of trapezium or height of trapezium is 1, so you don't even have to use that. This one goes from 0 to 1. This one goes from 1 to 3. This one goes from 3 to 5. And this one goes from 4 to 3. So the numbers are easy. In fact, this is probably on a non-calculator paper. So 60 seconds. Have a crack at that one. Even if you haven't got it in front of you, you can still use my screen to get the numbers and do the mathematics. Bad joke coming up. I dreamt last night, kids, that I was swimming in an ocean full of orange pop. And then I woke up and realized it was just a fantasy. Nothing? Nothing. Thank you, Maul and Katie. Johan, that's rude. Paris. Thank you, Tegan. Right. Well, thank you, Mia. I think they're great as well. They're getting us through a very tough time. Let's do some mathematics. So the triangle, half times 1 is a half. The next trapezium, 1 plus 3 is 4, half of that is 2. The next trapezium, 3 plus 5 is 8, half of that is 4. And then the last one, 4 plus 3 is 7, half of that is 3.5. So I need to add those up to get the total, 6, 9, 10. All right, and I'm fairly confident that almost all of us will have had 10 meters there, right? So that's an A-star question on a non-calculated paper, and you can do it, okay? Here's my next joke. Any questions? Anybody want to say anything? That's funny. Okay, I'm sure you can all do it. Now, the apologies for last week. I forgot to post the quiz. If you weren't in my Top Set Year 10 class, I scheduled it wrong, but you should have all just had the quiz go live 5 minutes ago. I'll show you the quiz because I had to make it from scratch. So let me show you it very quickly. Where is it? Oh, it is. Right, hopefully you can see this. So normally the answers to the multiple choice are attached next to the letters, but I couldn't get it to work for this one like that. So the answers are at the top. And then you have to click A, B, or C, D, right? It does say, make sure you read the instructions, find the area under each curve, use a strip width of 2 each time. Okay, so every trapezium you make must have a strip width of 2. And that's me being very nice because half of 2 is 1. Right, so I've set it up for you nicely. There's 5 of them. There's number 1, there's number 2, 3, 4, and 5. Right, nothing juicy. I've been very nice with the multiple choice answers. One of the answers for each question is pi. So you've got to be pretty daft to put that in. So I'd really appreciate you doing the quiz straight away, please. Now, let's talk about the rest of the week. Your mind math for tomorrow. Now, because this is effectively A-level work, in a sense, there's no specific mind maths task about the trapezium rule as below A-level. So the mind math task, I've just given you some straight up area of trapezium work, and I've also then given you another task on distance, speed, and time. Not difficult. I expect 2 greens. I have done a walkthrough vid, and please watch it. Talking of my walkthrough vids, thank you to the 11 of you that have subscribed to my YouTube channel. I thought I'd be able to retire by this week, having 1 million subscribers. I have 31. It's embarrassing. Please subscribe to my channel and make me an internet sensation. Yeah, so the walkthrough is there for the My Maths. Watch that, get 2 greens. And your manga high task this week that will go out on Thursday is to do with velocity time graphs. Okay, so make sure you get a gold on that. I've given you some extension work this week if you so wish to do it, right? So it's quite tricky. It'll be published tomorrow just after your My Maths. It's totally optional, but if you're up for it, have a go. The answers are there if you wish to self-mark. If you want to ask questions or send it in to me, I'd love to mark it. I'd love to see you have a go, right? But that's pretty much it. Get 5 out of 5 on this quiz now, because they're not difficult. Just take your time. Don't press any wrong buttons on the calculator. And have a lovely, lovely half term. Anybody got anything they want to say? Maybe would like to share with the group. I see Matthew Heath is on. Nice to see you, mate. First time. I hope you managed to catch all the lesson. If not, you can always go back and watch it on YouTube at your leisure. And thank you to Jamie Rizzi for leaving there without saying goodbye. Oh, shocking behaviour. Right. All the best, everyone. Bye-bye. See you soon. Get all your work done this week and enjoy a well-deserved, restful half term. And then we're straight back on it, first Monday back, okay? Any questions, just get in touch. Hello, Ben. I didn't even know you was there, mate. Ta-ra. Any questions, just get in touch. by Google Classroom, and I bid thee farewell. Mr. T out. Bye bye.